So welcome back. So the last electrical component that we said we would talk about is the transformer. Now, when we looked at the inductor, we realized that the inductor is made up of coil wire that are coiled, right? So if I have a wire that is coiled and there is a magnetic field, then it is going to store charges. Now we said that if we have two inductors close to each other, and one is able to store charges, it is able to induce a form of charges on the one that is lying close to it. And I told you that that is how, or that is the basis for transformers. So when we talk about a transformer, we are looking at two inductors placed at close proximity. So if you look at the image here, so this this is an inductor connected to an AC source. So we have that inductor connected to an AC source. Now there's going to be charges being built up at this region. Now, because there's charges built up at this region and there is another inductor here placed at close proximity, charges will be transferred onto this inductor. And that is how transformers work. Now, what do we use the transformer to do? It's used to do two basic things. It is used to, one, step up. When we say step up, mean that we are increasing. So it's used to step up or increase voltage, and two, it is used to step down. When we say step down, what we are trying to mean is what? Decrease. So there are some device, you see, let's take your home for instance. So let's take your home for instance. There are some devices that you use at home that requires what? Requires less voltage, such as your blenders. It requires less voltage. Your mobile phone chargers and those basic device. Now you see that your house is connected to the national grid, and so the voltage, um your house is connected to a local grid, and the local grid is connected to a national grid. So let's take Ghana for instance. Most of our energy or electrical power source is coming from Akosombo Dam. So the Akosombo Dam. So power is generated and distributed by Gridco. So Gridco, that is at the south part, and NADCO, that is at the north part of the country. You get it? So they are responsible for the distribution of power. Now, this power that is produced from Akosombo, it has high voltage. So you see in your areas, there's going to be transformers, right? Now, what is the essence of this transformer? Because your home cannot take huge amount of voltage, the transformers are there to what? Step it what? Down. So in the Ghanaian context, most transformers works as what? Step down. That is reducing or decreasing what? Voltage. Do you get it? So assuming, let's say 130 volts is being produced or transferred to your local grid, your transformer will step it down to, let's say, 25 volts, right? So that is what transformers are basically used for, used to step up voltage or to step down voltage when the need would be. All right, so let's look at this. So now the first inductor is what we call the primary transformer. The primary trans sorry, the primary core rather, not primary. So if you take the transformer, so this whole thing makes the transformer. This whole thing makes the transformer. This whole setup. So you can look here. If you look here, you see that there are coils of wire. If you can clearly see, let me use a bright color. Let me use a red color so that you can see. So this coil here. So if you exclude this section, this is an inductor. If you exclude this section, this is also another what inductor. But together they are the what the transformer, right? This whole thing is a transformer. So this is the primary coil. We call this the primary coil. Yes, it's here. Primary coil, and this is the secondary coil. Secondary coil. So if there's going to be a step down, so let's take the first condition, step down. The voltage at the primary coil will be greater than the voltage at the secondary coil because it's going to step it down. When it is a step up, the voltage at the primary will be less than the voltage at the secondary. Are you okay? Now, whether it's going to be a step up or a step down, it depends on the number of what of turns in the coil. So there is this calculation that we use or formula we use to determine the voltage that will be supplied to each of the coil depending on the number of turns they get it. So the formula is the primary voltage divided by the secondary voltage is equal to the number of turns in the primary coil over the number of turns in the secondary coil. And and so if I give you a question where I have the voltage in the primary coil, I know the number of turns in the primary coil, I give you the number of turns in the secondary coil, I can find the voltage in the secondary coil. Yes, so that will bring us to the end of this section. We'll take some example and we'll be good to go. Questions that we are going to try our hands on. So the first question, so let's look at the solution for the first question. They said that a step up transformer has a primary core with 30 loops. That is the number of turns. So the number of turns for the primary is 30. And the secondary core with 75 loops. So number of turns for the secondary is 75 loops. If the primary voltage is primary voltage VP is 25.0 volts, what is the secondary voltage? So we use the formula primary voltage over secondary voltage is equal to primary number of turns over secondary number of turns. So primary voltage is 25. Yeah, secondary we don't know. Number of turns in primary is 30. Number of turns in secondary is 75. So making V as the subject here, you cross multiply obviously. So 75 by 25 divided by 30. And we are going to get the VS to be, so VS going to be equal to 62.5 volts. So yes, so the voltage in the secondary coil is going to be what 62.5. Now, what type of transformer did they say it is? It is what? A step up, step up. So I told you that when we say step up, what do we mean? We are increasing what? The voltage. So the actual voltage in the primary was 250. Because it was stepped up, we increased it. The secondary is now what? 62.5 volt. Let's look at the second question now to go. So the second question, let's see how to go about it. So question 2, we have a transformer has 100 turns on its primary coil. So number of turns in the primary coil is 100, right? And 500 turns on its secondary. So number of turns in the secondary is what? 500. If the alternating voltage, if an alternating voltage of 2 volts is applied across the primary. So voltage across the primary is what, 2 volts. What is the voltage across the secondary? So the same thing, voltage across primary over voltage across secondary is equal to number of turns in the primary over number of turns in the secondary. So voltage across primary is 2 divided by voltage across secondary is equal to number of turns in primary 100, number of turns in secondary 500. So the zeros will cancel the 0. So we are going to get Vs by 1 is equal to what? 2 by what? 5. And so the voltage in secondary is going to be what? 10 what? Volts. So with this, we can infer that the transformer they were talking about is what? A step up transformer. And so that will be it. This is where we will end in terms of introduction to basic electronics. So the next thing that we are going to talk about, we are going to look at electronic material. So we look at insulators, what are they? We look at conductors, what are they? We look at semiconductors, why does conductors conduct electricity and insulators don't? We look at the atomic properties of conductors, and there is, I believe that you are excited. I'm also excited. So make sure to follow us, our YouTube channel, Educare Foundation. Share with your friends, share with your colleagues, because look, basic electronics has been made simple here. All right, see you next time. Bye.